An outlier can be defined as a data value that is numerically distant from a dataset. An outlier is a data point that falls outside the main pattern of data points, and it can be either the largest value in a given dataset, or it can be the smallest value in a given dataset. We will go through a couple of examples so you can see what I mean by this. So if I had a histogram that looks like this, we can see that this point is numerically distant from the dataset. Because of this data value can be classified as an outlier. Now in this dataset, we see that the number 9000 is significantly larger than all of the other data points, so this data value can be classified as an outlier. And in this dataset, the outlier is the number 3 because it is significantly smaller than all of the other data points. In other words, it is numerically distant from the entire dataset. Sometimes, the outlier in a dataset may not be obvious. In another video, we will show you how you can calculate outliers. Outliers can be thought of as data points that are very atypical and surprising. Because outliers are numerically distant from a dataset, they can affect measures of center and spread. Suppose a researcher decided to record the temperature of Winnipeg on July 1st for 7 years straight and got these results. We can clearly see that negative 350 degrees Celsius is an outlier because it is not a typical observation, especially during the summer. If we use this data to calculate the mean, we get negative 28 degrees Celsius. Obviously, we know that the typical temperature around this time is very warm and around positive 20 to 30, not negative 28. We got this result because of the outlier. The outlier was involved in our calculations, which gave us a skewed result. Therefore, we say that the mean is affected by the presence of outliers. To show how outliers affect measures of center and spread, I will compare the calculations with the outlier and calculations without the outlier. So with the outlier, we get a mean of negative 28, and with the outlier excluded from the dataset, you should find that we get a mean of 25.667. Now let's see what happens to the median. First, we'll have to numerically order the data. We can clearly see that 26 is in the middle of the dataset, so the median is equal to 26. Without the outlier, you should find that we get a median of 28.25. Now the mode refers to the most frequently appearing data value. In this dataset, the number 31 appears the most, so the mode is equal to 31, and without the outlier, the mode is still equal to 31. Let's look at the range. The range is equal to the maximum minus the minimum. With the outlier, you should find that the range is equal to 381, and without the outlier, you should find that the range is equal to 16. Now let's go over how each of these measures of center and spread respond to outliers. We had previously discussed that the mean was affected by the presence of outliers. When we included the outlier in our calculations, we saw that it really skewed the results. In contrast, we say that the median and the mode are resistant to the presence of an outlier because the presence of an outlier doesn't change their values as much as the mean does. The median only cares about the middle of a dataset, and the mode only cares about how frequent a data value appears. Now let's look at the range. We see that if an outlier is present, it can change the value of the range very drastically. This is because an outlier can either be the maximum value of a dataset or the minimum value of a dataset, and the range is always equal to the maximum minus the minimum. So the outlier will always be involved in the calculations, and as a result, it really affects the value of the range, just like how it affects the value of the mean. Lastly, we will look at the standard deviation. Since the mean is contained within the formula for the standard deviation, and since the mean is affected by outliers, by default, the standard deviation is also affected by the presence of outliers.